Hello, I'm Alejandra Perry, and this is my Science Fair 2021 through 22 project. How will plastic be affected when key components are altered? Introduction. When vinegar is amalgamated with heated milk, a moldable, irregular matter is produced. This substance is identified as casein, a type of plastic. What could occur when this process is modified with other constituents, such as honey, oil, or sodium chloride? Would that affect the production of plastic? Would it generate plastic at all? Below is partial of the casein molecular structure. However, that poses a question. What is casein? Casein is a protein derived from milk. It makes up 80% of milk protein, other 20% whey. Furthermore, casein is considered a plastic since it has molecular chains known as polymers. Polymers are considered plastics. When milk is heated, water begins to evaporate, making the proteins in the milk more prominent. When an acetic acid, such as vinegar, is imparted, the casein coagulates. In this chemical change, the acidic properties of vinegar rearrange the molecules of casein, forming curdles. And as you can see on the left, here would be an example of casein curdles. Hypothesis. If vinegar is mixed with vinegar and milk while producing plastic, then the resulting substance would be viscous because of the syrup-like consistency of honey. If sodium chloride is mixed with vinegar and milk while generating plastic, then the milk will dissolve and produce a diluted liquid because vinegar and salt compound into hydrochloric acid. However, a diluted addition of hydrochloric acid. If oil is mixed with vinegar and milk while making plastic, then the plastic will be generally unaffected because the vinegar and milk will suspend the oil. Materials per trial. 235 milliliters of whole milk, hot plate, 20 milliliters of white vinegar, 2 beakers, beam hood, tongs, 2 graduated cylinders, thermometer, fork or strainer. Only one of the following per trial. 15 milliliters of honey, 50 milliliters of sodium chloride, or 50 milliliters of oil. Throughout this PowerPoint, I will be referring to these substances as the test variables, since these are the substances that I'm testing for their reaction, for what they would yield when amalgamated with vinegar and heated milk. Therefore, here are the variables: independent, individual substances, controlled quantities of the substances, and the temperature of the milk; dependent, substance produced, and constant, environment temperature. Procedures. Pour 235 milliliters of whole milk into a beaker. Heat milk on a hot plate for about 20 minutes on high. You can heat for more or less if the milk reaches a temperature of 60 degrees Celsius. Pour heated milk into a clean beaker. This is to avoid burning. Decant 20 milliliters of vinegar into the milk. Add 50 milliliters of the test variable, honey, salt, or oil. It is crucial to pour the variable and the vinegar at the same time. Once the vinegar interacts with the milk, a chemical reaction is about to occur. Thoroughly blend these substances and wait for roughly 30 to 60 seconds. Extract the kernels from the remaining liquid. This can be done with a strainer, fork, etc. Place the kernels into a clear container. The remaining clumps should be clutters of casein. However, in this case, we wouldn't know what the substance produced this. I'm referring to this substance would be unknown because, if I'm not mistaken, this hasn't been done before. A chemical reaction between milk, vinegar, or test variable. So therefore, here would be the results. However, these are only the control trials, which has been done many times before by us, which would be just the 235 milliliters of heated milk with 20 milliliters of vinegar. So as expected, the kernels were produced as moist mush and had a somewhat stable form. The substance later hardened, becoming dense. However, it was more fragile than other plastics. In the controlled trials and the honey trials, the most casein was produced. So you can see here would be trial 1, trial 2, and trial 3 of the controlled trials. And now the trials with honey. The bumps protruded less, as the resulting substance had a mild consistency. Despite this, it still maintained its form for a short period of time. After being dried, the substance had similar visual properties to porridge. However, when felt, it had been similar to dough, semi-moist and moldable. This is ideal for creating small structures. Honey is adherent, therefore it transitioned the casein state into a viscous solid. So throughout the results, I will be making an analogy of when first produced and after being hardened. So when first produced, the honey had been very liquid, right between the state of being a solid and a liquid. But when hardened, it became a viscous solid, very moldable. As you can see, it looks very similar to the control trials, which I will revert back here, just for an analogy. You can see here, fairly similar, and a fairly similar production. However, as stated here, it had been semi-moist and moldable, very similar to dough. For the trials of salts, there is a tremendous contrast, as you can see. Very small kernels had been produced, though they were overall liquid. When dried, the casein resembled grains, while the other two remained liquid. When it comes down to the grains, these would be great for miniature details for a structure or filler. The salt and vinegar are likely compounded before the milk had. This would tarnish the vinegar's ability to react with the milk. So, this likely occurred for trial 1 and trial 3, at the exception of trial 2, where casein had been produced before hydrochloric acid had been produced, if I'm not mistaken. While for trial 1 and trial 3, hydrochloric acid produced, and as far as I know, there's no chemical reaction between diluted addition of hydrochloric acid and milk. So more than likely, it had been a physical change for physical change between diluted hydrochloric acid and milk, which would be why it remained appearing mostly like milk. It had no signals of chemical reaction, except for trial 2, where it did produce, and with different physical properties. Now, as for the oil, the oil diluted the chemical change. Only minuscule kernels were formed. Though these are mixed with the remaining liquid, this occurred due to suspension. The oil interfered, not allowing the milk and vinegar to contact because of the mixing. And when I'm referring to mixing, it would be just the presence of oil, occluding the ability for a chemical reaction to take place. So my hypothesis for oil had been the most erroneous of them all. Despite this, I still managed to take some type of quantities of their mass in grams of oil and salts, despite the very minuscule production. But as stated earlier, the controlled and honey trials produced fairly similar amounts of casein. They had very similar averages. So data analysis. The data implies that honey hadn't had any tremendous effect on the initial mass of casein. On the other hand, the trials that included salt created a scarce amount of casein that are difficult to measure. The trials that included oil formed even less. Oil cannot mix naturally with milk or vinegar, while salt can. When I'm referring to naturally, I meant in the sense of a physical change, including chemical change. But oil cannot mix because of the densities and other circumstances. So this would make a chemical change due to salt plausible, however, it did reduce the casein initiated. Most of the honey consists of glucose and fructose, types of sugars. Vinegar nor milk have any reactions with sugar, meaning the honey only affected the casein physically. This is simply an inference. However, I do suspect that it did affect it chemically, but I really wouldn't know how. Now, conclusion. Based on my results, all the variations of casein had differing properties, which can be used intently depending on its purpose. My hypothesis for each improvisation has certain aspects approximate to the results, however incorrect. When it came down to testing the variable honey, my hypothesis had been partially correct. When produced, the casein had been viscous. However, when dried, it became dough-like. Analyzing the results when including salt, my hypothesis had been correct. The salt would diminish the chemical change, except at exception for the second trial. where small bits of casein were generated. The milk and vinegar could have reacted before it salted, managing to produce minimal amounts of casein. Well, actually, trivial amounts of casein. So, as for the oil, similar effects occurred. However, my hypothesis had been even more erroneous. I originally predicted that the oil wouldn't have any crucial effect. In contrast, the oil plummeted the reaction of milk and vinegar. It's likely the density of the oil separated the milk and vinegar, never allowing them to mix. Nonetheless, my results exemplify that plastic can be altered for its intended use. So, in an analogy for the test variable reaction between milk and vinegar for oil and salt, in a sense, it had been fairly similar, except for, comparing the second trial of salt with the trials of oil, had been very similar amounts of casein had been produced. However, with the oil, it remained mixed with the remaining substance, while salts, the liquid had diminished. Applications. Utilizing these results, salted plastic casein could be made smoother, more durable, or efficient, relative to its purpose of formulating it. The properties of casein vary when composed of an additional substance. Therefore, a wide range of uses are available. So these would be only the results of casein production, including honey, oil, and salt. However, what if these were mixed with other substances instead? And wouldn't these cause other results as well? So, rather than purchasing already produced plastic, casein could be developed to accommodate the purpose it is being created for. For example, you might purchase a piece of material. In this case, it would be plastic. And it might not be as ideal as you'd like it for some type of structure you might be building or any other purpose. So you could directly formulate it using simple substances that are available at a local grocery store and with trivial quantities. So this would be very convenient. And this would be very convenient for mass producers as well, as mass producers could assemble casein as an environmentally secure option of generating plastic.